Okay, so see the first video if you want to see how we got this data in here. But again, just a reminder that each one in these cells represents a person. So for example, we have 51 people in our sample who were raised in the Muslim-Islam religion, but who eventually converted by the time that they took the survey as an adult. What we want to do now is create 3 separate tables. So this right here is what we would call our, write it like this, observed data. Okay, and I'm going to stretch that across, center it. So this is our data that we actually saw in our sample. And to make things a little nicer, we also want to create total columns, which will just keep track of the row totals and the column totals. Oops. Okay, now notice this formula here, just a side point, but it's worth pointing out that when I add C9 through D9, so this one and this one, I get this number right here. If I would add up these cells, notice down in this box, I would also get a sum of 58,227. I would get the same sum, and that's exactly what we should see, because this should give us the total number of people in our sample that are divided into one of these 10 boxes. Each person is in one of these 10 boxes. Okay, the next step is I'm just going to select all of this, and we're going to make our second table right here, and we're going to call this the expected data. So this one's just a little bit odd to adjust to, but what we're really looking at in this test is our null hypothesis would be it doesn't matter which religion you're raised in, the chance that you'll eventually convert is the same. The opposite of that would be, for example, that people who are raised in the Jewish religion might be less likely to convert than the others. Maybe those who are raised in Muslim religion might be more likely to convert, but there's some connection, some relationship between the religion you were brought up in and the likelihood that you'll convert religions. Whereas, again, the null hypothesis would be that you have the exact same chance of converting regardless of what religion you're brought up in. So to calculate this, first we would take these out. We're not going to change the total number of people we have in each religion. So this is going to stay the same. Let's paste those values. Same thing with, we're not changing the amount of people who actually converted. So these numbers are all going to stay the same. What are going to be different are what we would expect to happen if there's no difference between the religions in terms of how likely a person is to convert to another religion. So I'm born Jewish, I'm just as likely to convert as if I'm born in an Eastern religion, I'm born without religion, I'm born into a Christian upbringing. It really doesn't matter. I have the same likelihood of converting. That's the numbers we want to create down here. So how do we do that? To answer that, let's take a look at a question that we can answer pretty quickly, and that's what percent of people did convert? Well, we know that 50,818 of our sample kept their religion, and this number, 7,409, converted to a different religion than what they were brought up in. So we could get a percentage for each of those. Let's calculate that real quick. So we'll say this one divided by the total in our sample. So 87.3% roughly kept their religion, whereas could just subtract this from 1, but 12.7% converted. So if we're just as likely to convert regardless of what religion we're in, then a Christian, a person who is born in a Christian upbringing, should have an 87.3% chance of keeping their religion, 12.7% chance of converting. And we know that there's 53,474 people who are born into a religious upbringing. So to get these numbers then, we would just take 87.3% of the 53,000 Christians we have in our database, and we would do the same thing. Oops, let's go ahead and do that. Equals H9 times, total there. So we would expect 46,670 to keep their religion, 6,800 to change. Real quick, we can take a peek at what the actual was. So we can see that more Christians than expected kept with their faith than converted to a different faith. If this number was exactly 46,670, we would say exactly as many as expected converted away from Christianity. That doesn't tell us, though, about the entire population. We're still just talking about our sample. In order to figure out if this is true for the population, we're going to need to create a different table. So let's do the same thing we just did for the rest of these. If we want to save ourselves a little trouble here, let's put a $sign before the 9 and a $sign before the 9 here. And then we can just copy these down. I'm essentially doing the same thing that I did here. Notice again, just a real quick check. If we sum all of these up, we get 58,227. So we still do get the total amount that we're hoping to get. And if we would add across any row, we still should get that these two add up to this number here. Okay, and now we may take a little intermission here and take a look at a really interesting question from our sample data. Let's look compared to what we would expect, the number of people who we would expect in each religion to keep it, if it doesn't matter what religion you're born in. Let's see how many there are. Sorry, this is the expected, this is what we actually have. So there were more Christians than we expected who kept their religion. Jews, we would have expected 1,032. It was pretty close, but a bit down. These would be the ones who did not have a religion, and that's quite a bit lower. So we saw this group of people converting at a much higher rate than the other groups. Eastern, also, we would have expected it to be a little higher than it was, the number that kept theirs. And Muslims, same thing, a little bit higher here would have been the expected. In other words, more Muslims converted to another religion than we would have expected if religion had nothing to do with the conversion rates. Okay, now what we need to do is create our third table. And this is probably the most complicated table to understand what's going on. Just a real quick summary of what we're doing here. We're now checking how we could generalize from the sample to the population. So we know that in our particular sample, Christians were did not convert as much as we would have expected them to. Everybody else converted a bit more than we would have expected them to. What we want to see is this just probably our sample, or could we say that this is an actual significant trend in the population as a whole? And then interpreting that trend is a fun but entirely different question. So this is based on a formula. For each cell, we're going to take the difference between the observed and the expected. So these were Christians who kept their religion. we're going to square that, and then we're going to divide that by the expected again. So that expected shows up twice in that formula. And because of the way I coded those cells, we can just copy and paste all over. Okay, and let me also adjust these to be what they were originally. They're adding the rows and columns. And I also put these in percentages just so we could keep track of what was going on. Final step now, we finally, excitingly, get to figure out our p-value for the test. Let me do this by doing chi-squared dist rt. And then we're going to need to click that bottom right, which is the total, the sum of all the chi-squareds for our table. And then degrees of freedom. So what degrees of freedom is in a chi-squared test? The data itself, so not counting the total columns here. Let me get them. Data itself, we're going to basically take the number of rows minus 1, so that'd be 5 minus 1, times the number of columns minus 1, so this would be 2 minus 1. So if you just picture getting the entire data and then just taking it up a row, taking it over a column, that number of cells is our degrees of freedom. So in our case, our degrees of freedom is 4. Hit that and we get our p-value. As it turns out, the p-value for this particular test we ran is so extremely small. It's not actually 0, it's 0.00000, but it's so small that we can be almost certain that even in the population itself, the chance that you'll convert is not the same. It does depend somehow on the religion that you're brought in. Certain religions are more or less likely to convert than others here in the US over the past 4 decades. We could also have conducted got the same p-value without even doing this table, and that would be by chi-test, and we would select our expected values, and our observed, then our expected. And this would give us the same exact result as the one. Typically, I would just do that. I wouldn't have you do unnecessary calculations. The reason why I think it's valuable here is because this table does give us some information. It lets us see, okay, we rejected the overall thing. We know that not all faiths are as likely to convert as other ones, but we want to see where some of that differences came in. So we're looking for the really big values here. And we can see that one of the biggest ones was people with no religious upbringing who did convert. That was much different than what we expected it to be. And another way that we might get that, let's look at our actual data, is looking at the conversion, or let's look at the rate of people who kept their religion for each of these major faiths. I'm going to just change this to percent, a little more. So you can see that just a little over half of these people without a religion did keep their faith. Almost half converted to another one. The Eastern religions, almost 2/3 kept their faith. 1/3 of them converted to a different faith. And you can see that Christians, almost 9 out of 10 kept their faith in the US, whilst the other 1 out of 10 converted to a different belief. Of course, we could get much more nuanced look into how these rates have changed over time. Is it different now than it was 20 years ago? But this is the original result.